Good day, everyone. Hope you have a lovely day. So, with me here is a solar charger controller that came in as no power. Yeah, we received this from one of our rural customer. He said the solar charger controller just went off. So I never fixed something like this, but we have to diagnose and fix this thing. Huh? Because it is an electronic device, so we have to do something. So what is this? This is a solar charger controller. I believe what this thing is doing is controlling the power which is coming from the solar system to the batteries. It's working in between the solar and the batteries just to regulate the power that is going to the battery to prevent like under voltage, over voltage. Because sometimes when it's too sunny, there will be too much power which is coming from the solar, and it's very possible without this charging controller to have like fluctuation of currents and voltages, and that can damage the batteries. So they use this thing. That's what I believe this solar charger controller is working. So what do we have here? We have the sign for the solar input here, plus and minus. And on the middle, we have the battery sign. So the power from the solar is this is solar system input. Here we have the battery output, and that output for the lights, 12 volts lights, those DC lights which are working with 12 volts. So what I want to do, let's supply power 12 volts. Let's take our power supply as the battery. Let's assume that this power supply is the battery. I want to see what will happen here. Plus, minus. Pressing the power. All these is switches which I don't know what they are doing here. I think it's to control the digital thing on the on this LED display. And we have nothing. And we have like 17 milliamp standby current. Okay. Again, it's doing nothing. So we have some kind of power issue. We have some screws here. Let's get inside this. I'm curious to see what we will see inside this. What can be faulty here? Fixing something new is very nice. 4 screws. Okay. This looks nice. So that the inside of the controller, we don't have too many components here. Let's check with the multimeter. What do we have here? We have the plus and minus for the battery. Where this plus is going. I can't see where the plus is going. But here we have like 30 amps fuse connected in parallel. Those two green things. Let's check for those fuses. This one is good. And this one is good. And now the next step. We have some diodes here. I'm just checking random components. And this diode is shorted, 0. This capacitor is short. Yeah, this area seems to be blown up. Huh? Let's check together under microscope. Here. Let's see. What do we have here? Huh? What do we have here? Let's see. What do we have here? We have this resistor. The diode is gone. We have another capacitor here. This capacitor is shorted and this resistor. And the problem, we don't have schematics like always. So what I would do, let's try to replace that diode in that resistor. Ohms. Seven mega ohms, 7.6 mega ohms. Okay, we'll see about the resistor. We'll see about that. But at the moment, let's check out. I don't think the diode and the capacitors, they are all shorted. What I will do, I'll take that capacitor, that diode first. I'll check out the diode first. Because I can see on a microscope that the diode is completely gone. Diode is out. Let's check that capacitor again. Let's check out that ceramic capacitor. Let's check again for short here. So there's no more short anymore. So we need a ceramic capacitor. And a diode. So I don't know what happened to this controller board. Let's replace those components. Now a capacitor. I'm not sure about the value of the capacitor. So what I'll do, I'll take one from a laptop motherboard. You know those in ceramic capacitors on the 19 volts power line. I'll take one there. The capacitor is now in place. We now need a resistor. The problem, we don't know the value of this resistor. That is the biggest problem. So I need to take down this blown up resistor. Hmm? We now need a resistor. If we can get one, Come on, the resistor is running away. You stay here. Fine. What resistor did you put here? Or we're supposed to do the measurement before we put it on the board. I don't think this resistor is right because the resistance is very low. We need a resistor with the high resistance. Oh, high resistance resistor. I'm trying to look for a proper resistor here. Let's test another one. Huh? Now the hard part is to to get a proper resistor. Diode. No. Let's put another one. I'm not happy with the resistance of this resistor. Good. Let's measure that one. Ohms. 60, 70 something kilo ohms. Diode. It's now better. So what I would do, you can see those pins here. You see those pins? Here we have some switching MOSFETs. That's how this controller is working. It's being controlled by those MOSFETs. So here we have 6 pins, meaning to say on the other side we have 2 MOSFETs, and here on the other side we have 2 MOSFETs. So I will check for those MOSFETs for short. You can see this MOSFET is gone. This one is gone. Good. Good. And here, this looks like another MOSFET. Good. Here. So we have 2 MOSFETs. We have 2 MOSFETs which are not good. Huh? So you understand why those resistor and the diode died after the MOSFETs were blown up. We have 2 blown up MOSFETs here, or maybe can be 1, but I think it's 2. You know, I need to get access to the other side of this board for easy replacement of those MOSFETs. And you see those MOSFETs? Yeah, this one is clearly gone. And usually they are using channel N MOSFETs. So again, which MOSFETs to replace here? So the first ones, they are gone. The first 2 MOSFETs, they are gone. Let's check for this MOSFET. What about this one? So this one was reading a short because they are in parallel mode. So if one MOSFET is shorted, the next one will also read a short. But actually, we have one MOSFET which is shorted, not 2. This one, RFB3206. Let me look for the MOSFET and we'll try to replace the MOSFET. I found something. I found something. I found this MOSFET, which is totally different, but this is an N-channel MOSFET, which is performing same task. So let's try with this MOSFET. Let's try with this MOSFET. It must work the same. Hopefully this thing will work again. Let's assist the soldering iron with hot air. Fine. So now we need to test. We need to test to see if this thing is working. I think we can now test. I think we can now test. We have 12 volts there on the power supply. Let's test to see if we have any display. And then plus taking no current at all. No, our thing is dead. Why? Hmm? What have you done wrong here? I think okay. Let's try something. Because I'm suspecting on that resistor, probably we'll put a high value resistor. Because we don't have a schematic, obviously. So it's very possible that let me jump this with this resistor with a wire. Maybe the value of resistor is very low. Power on, and it's working. Huh? Check on the display meter. It's working. Huh? If I release, it's not working. So let's go back and fix the resistor. Let's go back in time and look for a proper resistor there. Here. Here. The resistor that we put is not the right one. It's not the right one. This resistor, good. Let's see the value of this resistor. Zero ohms. 3 ohms, that should be okay. That's the resistor we are looking for. You know, sometimes I'm very wrong. Sometimes I'm very, very wrong. Yeah, the board is too hot. Let's wait and check. Let's test now our regulator. Plus, this is minus, and this is plus. We are just assuming that the power supply is the battery in this case, and I set it to 12 volts. So plus, and it's working. You can see the display. It's just on automatically. All the writings on the display. You see? And it's working fine. Huh? So check the display. Everything is working fine. You can see it's indicating on the right side, that is a lamp where these connectors, you can connect the LED here, or we can check for output. I think we can do it. Let's check for output on those connectors for the bulb. Okay. And check on the screen, exactly 12.19 volts. So even this output, if we connect a 12 volts bulb with a DC bulb, it will power on. So basically the job is done. What was the fault here? There was any channel MOSFET. Because they were in parallel mode, the other MOSFET was reading a short. So we managed to fix this one. I'm happy if I fix something which I didn't fix for the first time. So let me put all together and then we'll do the final test. I have put all together, and now is that moment to do the final test. So like what we said, here on the middle, you can see the battery sign. We have plus and minus. We have the sign for the solar input. The power from the solar is coming here and is being regulated and controlled, and we have stable voltage which is coming to charge the battery. That's how this thing is working. And here we have another output to light up DC 12 volts DC bulbs. This looks like a, a good device if you are using solar system, because is stabilizing the voltage which is coming from the solar panels to prevent like overcharging of batteries, over voltage, things like that. So if you connect the plus here, automatically it's coming on. You can see on the display we have the battery, we have the sign here for the bulb, for this output which is outputting 12 volts, and we have the panel sign. Can you see? And we have some control things which I don't know what they are doing here. But the most important thing is our regulator is now working. So I'll stop this video now. Like, subscribe, don't forget to turn on the notification bell. I don't feel bad if I spend like half an hour trying to fix something which I don't know, because at least I've learned something, that MOSFETs, they are dying on inverters, they are dying on controllers. This just, there's no need to check on that on Google, because I know these days they are using N channel MOSFET. I just took another N channel MOSFET from the inverter board and I replaced this dead MOSFET. And obviously on that diode and ceramic capacitors which was shorted, and also we replaced the blown up resistor. So see you on the next game. Bye.